1939, at Adolf Hitler's request, the Nazis were developing a bomb that would be so powerful and destructive they would surely win the war. Scientists were researching the possibility of taking radioactive particles and splitting them apart. Albert Einstein wrote a letter warning President Roosevelt about the plan and its implications. The U.S. military initiated its own top-secret research program. It was called the Manhattan Project and was supervised by General Leslie Groves. In the development process, American scientists knew the hazard of chemical radiation poisoning to both researchers and the environment would be significant. Part of the Manhattan Project involved development of a new type of filtration that could be used in research facilities where radioactive materials were used, such as Los Alamos Laboratory in New Mexico. The Arthur D. Little research firm was contracted to develop this new type of filtration. The new filters must be so sophisticated that even microscopic particles 1/300th the size of a human hair would be trapped. Ironically, they did not have to look far to find what they needed. British agents had smuggled top-secret plans out of Germany for a new type of gas mask filter that used microfine asbestos paper. The Arthur D. Little research firm decided to use the same design, improving it where they could. The resulting filters were called nuclear filters, or absolute filters, because they were believed to filter out absolutely everything. Without a doubt, absolute filtration helped make possible the development of the atomic bomb. After the war was over, and after the plans for absolute filtration were declassified, the Arthur D. Little Company started a separate company to manufacture and sell their filters. The company was called Cambridge Filter Corporation and would be a commercial enterprise marketing absolute filters to the fast-growing nuclear power industry. In 1961, an engineer named Humphrey Gilbert first used the term HEPA to describe these high-efficiency filters. HEPA was an acronym for High Efficiency Particulate Air Filters. Ironically, it wasn't until the early 1960s that Cambridge and other HEPA filter manufacturers stopped using asbestos paper in the filter media. Within a few years, HEPA filters would be one of the chief lines of defense against the very product they were once made from, asbestos. So what's so special about HEPA vacuums? They cost a lot more than conventional vacuum cleaners. Is it really that big a deal? An average upright vacuum with new filters may have an efficiency of anywhere between 50 to 75%. This means that 50 to 75% of the particulate is captured by the filter. This also means that 25 to 50% is exhausted into the air. As the filters collect more and more debris, the efficiency is actually reduced, and a greater amount of particulate is exhausted. If a vacuum is used to pick up hazardous materials like asbestos, mold, or lead, the most dangerous particles, the invisible ones, are the most likely to become airborne. Microscopic particles of asbestos, lead, toxic mold, or other hazardous materials can stay airborne for hours, even after the vacuuming stops. For this reason, state and federal regulations require the use of HEPA vacuums, HEPA-filtered respirators, and HEPA-filtered exhaust systems whenever hazardous materials are being disturbed. HEPA vacuums are rated in several ways: filter efficiency, vacuum suction, and vacuum strength. Filter efficiency is listed in a percentage. For example, true HEPA filters must capture 99.97% of the particulate down to 0.3 microns in size. That means that for every 10,000 particles in the air or on the ground, only 3 may get through the filter. HEPA filters must also capture particulate down to 0.3 microns. A micron is 1/millionth of a meter. A piece of household dust might be 2 or 3 microns in size. 0.3 microns is 1/300th the size of a human hair. HEPA filters must be tested and certified to be 99.97% efficient down to 0.3 micron sized particles. Any filter that does not reach that standard is not to be used in hazardous material pickup. A second measure of vacuum efficiency is the amount of suction. This is often stated in terms of cubic feet per minute, or CFM. CFMs are the amount of air the vacuum can draw in 1 minute. The minimum CFMs for a HEPA vacuum should be 85 to 90 cubic feet per minute. A third measure of vacuum efficiency is the power or strength of the suction. CFMs measure the amount or velocity of air. Water column lift, or WC, measures how strong the suction is. Water lift is measured with a pressure differential, or magnehelic gauge. If you took a 1-inch tube with water in the bottom and held it vertical, how high would the vacuum sweeper lift the water? This is what a magnehelic gauge measured. You should look for a vacuum that has at least 60 inches of water column lift. And don't be confused by horsepower or amperage ratings on vacuums. They don't really give a good base of comparison between various models. Just because one vacuum has a 2 horsepower motor and another has a 5 does not guarantee the 5 horsepower has better suction. It's best to look at CFMs and water column lift. In order to give true HEPA filtration, filters must be tested. HEPA certification is regulated by the American National Standards Institute. In order to be certified, a HEPA filter must be challenged with an aerosol known as diethyl phthalate, or DOP. DOP is a type of oil with standard-sized molecules. DOP aerosol is introduced to the downstream side of the filter and the vacuum turned on. A special light-sensing meter is then used at the other end to measure if any of the microscopic particles are able to penetrate the filter media. At Fortress Environmental, we not only require that HEPA filters be DOP tested by the filter manufacturer, we also test them again ourselves after they've been installed on the vacuum head. This way, you can be confident that your HEPA vacuum will function at peak efficiency if used in accordance with manufacturer's specifications. A true HEPA vacuum is no mere shop vacuum. HEPA vacuums typically cost several times more than shop vacs, and like any equipment, must be used and maintained properly to ensure safety. When you first purchase a HEPA vacuum, and each subsequent use, it's a good idea to perform a basic safety and systems check. Check to make sure the vacuum head is fixed securely to the tank. Fortress vacuums utilize a stainless steel locking clip to guarantee no accidental opening. Next, attach the hose to the intake port, making sure it's firmly attached. Turn the vacuum on and check the suction. Your HEPA vacuum should have enough suction to pull your hand tightly into the hose. If it does not, it's time for filter maintenance. Typically, your HEPA vacuum will be used in the pickup of hazardous materials like asbestos, lead, or toxic mold. Various state and federal regulations apply to the disturbance or removal of these hazardous materials. Depending on the job, personal protective equipment like filtered respirators, disposable coveralls, boots, gloves, and headgear may be required. Because of the risk of exposure to hazardous materials, it's important when using a HEPA vacuum to observe all state and federal regulations, as well as a few common sense rules. Always plug your HEPA vacuum into an approved receptacle. Fortress HEPA vacuums run on 110 volts and draw about 8 amps. Beware of attaching long extension cords between the vacuum and the receptacle or running other power tools on the same circuit. Never dry sweep hazardous materials. Use a HEPA vacuum to minimize the danger of increased exposure. Always handle a HEPA vacuum with care. Never stand on it or drop it from a ladder or scaffold. Always carefully lower it to the ground. Never eat or drink or chew gum when HEPA vacuuming hazardous materials. OSHA regulations forbid the presence of food or drink in contaminated areas. Always inspect your HEPA vacuum suction before each use. Make sure the head is securely clipped to the tank so that no hazardous particulate is released into the work area. For maximum safe vacuuming of hazardous materials, it is recommended that a HEPA vacuum have 3 stages of filtration. On a Fortress HEPA vacuum, the first stage, after the collection tank, is a cloth Dacron filter bag that wraps like a mitten around the HEPA. The Dacron cloth used in this mitten provides 40 to 50% efficiency and collects most of the visible debris. The second stage of filtration is called the impact filter. The impact filter is a small, fibrous filter that protects the main HEPA filter from damage or impact by sharp objects, as well as providing another barricade against larger debris. Fortress has 2 types of impact filter, standard and antimicrobial, for use in restoration and mold cleanup projects. The third stage is the HEPA itself. Fortress HEPA filters are DOP tested and factory certified to be 99.97% efficient down to 0.3 microns. In fact, Fortress vacuums are even more efficient than the minimum requirement. Fortress HEPA filters are Type A HEPA filters containing approximately 18.5 square feet of glass fiber filter media. Gasket material is oil resistant, expanded closed cellular rubber. Separators are corrugated aluminum, 0.038 millimeter thick. For maximum safety and efficiency of your HEPA vacuum, it is essential that each of these stages of filtration be maintained properly. Maintaining the filters on a HEPA vacuum is the most important way to ensure safe, efficient operation. Proper filter maintenance on a HEPA vacuum involves 4 easy steps. There may be specific state or federal regulations depending on the type of material you're vacuuming. There may be a requirement for respiratory protection or protective clothing. If you don't know for sure, consult regulatory authorities. Step 1. Remove the head. Empty the canister. Unlatch the 3 locking stainless steel clips and gently lift the head. Using a spray bottle with water, wet down the contents carefully to minimize dust release. If you're picking up regulated hazardous materials such as asbestos, you must place the contents in a properly labeled 6 ml disposal bag. On a Fortress B20 HEPA vacuum, the second step is removal of the Dacron filter mitten. The Dacron filter should be lightly misted with water to keep dust to a minimum. The third step involves removing the impact filter. You must first remove two nylock nuts that attach the bag standoff and filter retainer bracket. Step 4. Remove the old HEPA filter. Remove the HEPA filter, lightly misting with water if necessary. Put it in a disposal bag with other contaminated waste. Install clean filters. Remove the new Fortress HEPA filter from the box. Be careful not to damage the fragile filter in any way. Make sure it's the correct filter for your vacuum. Inspect it for punctures or tears, and make sure the rubber gasket is intact. Place the filter, gasket down, onto the vacuum head. Next, attach a clean impact filter over the end of the HEPA. Tighten the two nylock nuts with a socket wrench, making sure that the rubber gasket material compresses at least 50%. Now put on a new Dacron bag, and your HEPA vacuum is as good as new. With dozens of HEPA vacuums to choose from today, how do you select the right HEPA vacuum? There are at least 3 considerations in the selection process. Make sure your HEPA vacuum offers true HEPA filtration. Make sure that it is DOP tested and certified to be 99.97% efficient down to particles 0.3 microns in size. The second consideration is performance. When comparing HEPA vacuums, be sure to compare suction and velocity, not just horsepower and amperage. Horsepower and amperage ratings can be misleading. A true HEPA vacuum can cost anywhere from $400 to $3,000, depending on several factors. Fortress HEPA vacuums are value-priced, poly construction, with a 1-year warranty on the motor and 2-year warranty on tank and head components. Our dent-proof, rust-proof poly tanks are rotationally molded and seamless in construction. Intake ports are molded into the tank to minimize the risk of leaks, and casters are threaded into the tank to ensure they won't fall off. All in all, Fortress HEPA vacuums give you the best value in the HEPA vacuum market today. In terms of capacity and quality, you won't find a better value anywhere than a Fortress HEPA vacuum.